Hi everyone, in this video we're going to practice the steps of a linear programming problem of finding the maximum or the minimum value, and then the graphing step as well. Alright, so here's a problem from page 409. Evaluate the profit function for each vertex and determine which vertex gives the maximum profit. So at this step we've already graphed the constraints. Okay, gotten some sort of a region here. We've found the corner points, and then we know from Danzig's work that the maximum or the minimum value is going to occur at one of those vertices. Alright, so which one is it? Well, we have the vertices, so what I need to do are just substitute these into the profit function and find the profit that goes with each one. Alright, so the profit that goes with 0, 0. So we just go through and think of how a computer would do this. We would usually write a program to do this. But if you're doing this by hand, then you substitute in all of these values. Okay, so I'm going to replace x and y in this function with 0 and 0. And then that kind of makes sense. Okay, 0, 0 gives a profit of $0. 9, 0. So I would substitute in 9 for x and 0 for y, and then I would have 85 times 9 is 765. That's the profit that goes with that vertex. Okay, and then do the same thing for the other two. Okay, 85 times 0 plus 132 times 3, that's 369. Alright, and then 85 times 7 plus 132 times 2, and that is, let's see, let me grab a calculator, and that's 859. Okay, so then we need to determine which vertex gives the maximum profit. So I'm just going to look through and pick out the biggest profit. Well, that's 859. And then the vertex that goes with that is 7, 2. So 7, 2 yields the maximum profit, and then if you were asked what is the maximum profit, the answer would be $859. Alright, let's practice the graphing step. So we need to graph these constraints, find the vertices first, and then plug them into this objective function, and this time we're asked to find the minimum value. Okay, so graphing lines. The first one, I would probably use the intercepts for this line. Okay, so if we let x be 0, then I have 4y equals 200, and y is 50. If I let y be 0, then I have 5x equals 200, and then I get x is 40. Okay, so I can graph that line. 2x plus 3y equals 108, so if I let y equal 0, switch that up. Okay, if I let y equal 0, then x is 54. And if I let x be 0, then I have 3y equals 108. And x turns out to be 36. Okay, and then x equals 30 and y equals 40. Those are, vertical and horizontal lines. So I think we can use the shortcut to graph those rather than finding points. Alright, so let's make a graph. Now I'm going to color code these, so I'll call this the blue line, I'll do a green one, I'll do red, and I will do yellow. Alright, so the blue line, here's the points. Okay, green line. And then the red tells me I need to go to 30 on the x-axis, and the y tells me I need to go up to 40. So looking at all of these numbers, I noticed that the largest value for y is 50, and the largest value for x is 54. So that gives me an idea of the scale that I want to use. And I'm going to go by tens. Okay, so let me draw an axis, or two axes here. and I want to kind of fill up the space that I have, so I'm going to go by tens. I'm going to space this out and use 4 lines. That's going to be 10. Okay, so there's 10, there's 20, here's 30, 40. Let me see if I can squeeze this in. Just barely. Let me move one of my lines. Let me shift this guy down a little bit. Okay, that should do it. So I've got 10, 20, 30, 40, and 50. Okay, and then the x's. Here's 10, 20, 30, 40, 50, and I need to go to 54, so I'll throw a 60 in there. Alright, so graphing the blue line, I need the points 0, 50, and 40, 0. Okay, here's 0, 50, here's 40, 0, and connect those. Alright, and then the green line, I need 0, 36, and 54, 0. Okay, so here's 30, here's 40, here's 35, so 36 is right about here. Alright, and 54, 0, that's right about here. And connect those. Okay. These are inequalities, so I should also look at the shading. So if I use 0, 0 as a test point in these equations, then I end up with 0 is greater than or equal to 200, that's false, and 0 is greater than or equal to 108, also false. So I'm actually shading the opposite side from 0, 0 for these two lines. So I'm shading above the blue line and above the green line. Okay, and then the red line, x is less than or equal to 30. So I find 30 on the x-axis and put a line through that. Alright, and then I have had, let's see, y is less than or equal to 40, so I find 40 on the y-axis, put a horizontal line through that. How about shading? X is less than or equal to 30, so a test point of 0, 0, that's true, so I want to shade to the left of the red line, and similarly if I test 0, 0, I'm going to be shading below this yellow line. So follow all of the arrows, see where the shading is, and ultimately we come up with this region as the feasible region. This is the only spot on the graph that agrees with all 4 of those arrows. Okay, vertices. I have one that I can pick out really easily, this one. Okay, its coordinates are just the 2 from the horizontal and vertical lines. So this is the point 30, 40. Alright, I have 2 more that I at least know one of the coordinates right away. I have this one, and from that yellow line I know that the y-coordinate is 40. Okay, now the x-coordinate, I'm not sure right now, so what I need to do is go back and look at the system of equations, the yellow line and the blue line. Oops. Okay, yellow and blue. And okay, and what I can do is solve this by substitution. I know y is 40, so I'm going to plug that into the first equation. So 50x equals, 50x plus 4 times 40, and temporarily I'll pretend that that's an equal sign, and solve for x. So I get 50x plus 160 is 200, which means 50x is 40. Oh, sorry, 5x. Seemed a little bit off. Okay, there we go. And divide by 5, x equals 8. Okay, so that's the point 840. All right, another one. This one's not quite so bad. I at least know the x-coordinate from that red line. I know that this is 30 something. So this is the point that is on the intersection of the red and green lines. So I'm going to go back and look at those two equations. Okay, red and green. And again, I'll solve by substitution. So I know the x-coordinate. I know x is 30. I'm going to substitute that into the first equation. All right, and solve for y. So we have 60 plus 3y equals 108. Subtract 60, 3y equals 48. Divide by 3, y equals 16. Okay, and then we have one more. We have this point that's the intersection of the blue and the green lines. I don't even have a guess for this point because it seems to be kind of in between some of these lines. Maybe the y-coordinate is 20, but I'm not 100% sure about that. So I'm just going to solve this either by substitution or elimination. All right, so let's look at blue and green lines. And I kind of like the looks of elimination here. So I'm going to multiply and eliminate I'll just choose the x's. Okay, so 5 and 2. So I'm going to multiply the first equation by 2. And I'm going to multiply the second equation by 5. And I need to make one of these negative, so I'll choose the second one. So the first equation becomes 10x plus 8y, and then I'm going to pretend for now it's an equal sign, is 400. And the second one becomes negative 10x minus 15y equals, let's see, 108 times negative 5 is negative 540. And then add. So we get 10x plus negative 10x. That's eliminated. 8y minus 15y is negative 7y. And 400 minus 540 is negative 140. Divide by negative 7, and y equals 20. All right. Then substitute that back in to one of these equations and solve for x. So I'll choose the first one. So 5x plus 4 times 20 equals 200. So 5x plus 80 is 200. Okay, 5x equals 120. And divide by 5, x equals 24. So the point is 24, 20. All right, there we have it, the 4 vertices for that feasible region. So now I need to find the minimum for the objective function. So this gives me the 4 points to plug in, and I'm going to be plugging them into this function. This one has a z, it's just kind of a generic letter here. It's not a profit or a cost. Okay, in this case, if we had a word problem here, maybe we would use a P or a C to better reflect the problem, but this one doesn't have a story that goes along with it. So here are the vertices, and I'll go through and make these substitutions. So I have z equals negative 30, and I'm going to plug in 8 for x and 40 for y. Okay, and then just go through and do the same thing, substituting in all of these different x and y values. Okay, and so forth. And then go ahead and work these out, and let me just skip forward and I'll write out what the answers are for z in just a second. Okay, 40 times, 16. Those should be hundreds. Okay, going too fast here. 100, 100, 100. Okay. So here are all of the z-values that I'm getting. And the goal here is to find the minimum, so I just want to look through and find the smallest one. So the minimum value would be z equals 700. Okay, we'll stop there, and in the next video we will put all of these pieces together and go through a couple examples of solving an entire linear programming problem.